Good evening. My name is Bayo Vindipe. I serve as the Dean of the Panos College of Engineering, and it is my pleasure to welcome you all to this event. I'm not going to spend a lot of time because I know you probably have a lot of celebration to get to later on today. But I want to thank you all. Thank the all members of the families of our students, our faculty and staff. Everyone that has been part of the support system has brought you all to this particular moment. And I, on behalf of everyone, the Grand Valley State University team, just want to thank you all for supporting your students. It hasn't been easy. Being and studying engineering is hard. It's tough. And so today we are here celebrating the achievements of the past couple of years. To get us started, I would like to introduce our keynote speaker for this evening, Mr. Tom Kennedy. Mr. Kennedy is the co-founder and general manager of Polar Medical, an orthopedic medical device company focused on bringing excellence to often overlooked areas of surgical instrumentation. I met Tom last year, I think it was the first time we actually met. And in that time, he has shown and demonstrated a strong commitment to our college and our program. And in the spirit of his entrepreneurial mind, he has constantly inquired from us how he can work with us, how he can collaborate with us, and how he can make us support us in our effort to be better. He's a proud graduate of Grand Valley State University Sidman College of Business. Thomas spent the past decade in the medical device industry, 6 of those years working alongside surgeons as a mechanical and design engineer. He started his career in a GE healthcare leadership development program where he managed a $2 million conversion of an assembly plant into a global distribution center for CT and PET imaging, PET imaging systems, including designing packaging for worldwide distribution. So he's coming to us with a lot of experience, industrial experience, and background in product development and innovation. He has hired and mentored and worked alongside nearly 10 GVSU engineering co-ops and graduates. And he lives in West Michigan with his wonderful wife of 10 years and their 3 children. Please join me in welcoming Mr. Tom Kennedy.
Hello, everybody. Thank you for the Padnos faculty and staff for welcoming me here today. It's a pleasure to be here and just an honor to speak with you guys as you're kind of finishing your time at Grand Valley and in your engineering degree. So I know that there's going to be more people who speak to what the ring that you're receiving symbolizes, but there's just a couple things that I wanted to say to comment on it. That stainless steel ring that goes on your pinky finger of your working hand, that hand is going to be an important part of your life. It's going to be the hand that will help you type, it'll help you sketch, wire, test, troubleshoot. It's going to help you carry things. With it, you may solemnly hold a pen to sign off on a document, putting your name, your signature, yourself on the line in front of other people. Or it may simply be used just to scratch your head as you're trying to explain a relatively complex engineering concept to someone who has never even heard of an engineering concept before in their life. It's interesting, but it's deliberate that the pinky finger was chosen. I think it's interesting that I didn't realize this until relatively recently, but it is responsible for up to 50% of your grip strength in your hand. And so it's the smallest finger on your hand, but it's responsible for a very large amount of weight. But we're not here to talk about your physical strength. We're here to talk about the strength of your commitment to the obligation that you're going to be carrying as an engineer. Rarely in your career will opportunities to display your ethics show up as big moments, but it's going to be an accumulation of small moments over the course of your life that will develop a pattern of behavior, for better or for worse. I got the opportunity to tour the senior showcase yesterday, and I was very impressed. I definitely expected some of the polished posters that you guys had, the elevator pitches that you practiced, but there was a couple things that I noticed as I was there. I saw a project that had taken medication dispensation, which is a very real problem and concern in the medical field, and had made it simpler and safer. I saw projects removing human variation from processes where variation can quite literally kill a process. I saw projects designed to eliminate boring, repetitive, menial, or undesirable tasks. And while not all of them were in manufacturing, they spanned from automotive, consumer, industrial, health. The range was wide, and every one of them was directed at something meaningful. I think you should take pride in those projects. You guys did an excellent job. And everyone that I interacted with, yeah, let's give a round of applause to them. I was very impressed by the ability of everyone that I interacted with. I think I got to speak with 7 or 8 of the different project folks. Every single person that I interacted with was able to succinctly explain to me what their project was, why it was important, what they had contributed, and not only what they had contributed, but what their teammates had contributed to that project as well. And that's extremely important because engineering is a team sport. You are rarely ever going to do something on your own. You need to be able to rely on people around you to be able to contribute in different areas, as I'm sure you come to realize. There's one thing that I really want you to take away from today, if I can impart any sort of wisdom, which is just to understand your why in life. It's easy for, in any situation, it's easy to, over time, start to lose grasp of what your why is. So in any situation, know why the project that you're working on matters, know why the requirement is written the way that it is, know why the tolerance is tight in one spot and not in another, know why the customer is asking for something that they think they need, they may or may not need it, but they think they need it, know why you took the job, and know why you're still in it. I say this just because I watched what happens to people who lose their why or who never had one in the first place. Their work drifts, their career drifts, their lives drift. You can design the coolest new device, the most streamlined application, the best performing widget in your category, but none of it will feel like anything if you are not motivated by why you did it. A strong why will give you strength and perseverance. The obligation you are about to accept is more than anything else the beginning of a why. The people who will use what you will build, the people who work next to you, the public who trusts you to do work honestly, that is a why that's worth having. And this obligation you're undertaking is a start to that. Once you have a why, the day-to-day of engineering starts to make more sense. CAD, PFMEAs, control plans, requirement documentation, revision, control. These are all tools that will serve you in your career. And they're part of how your why survives contact with the reality of life. A clear CAD model prevents a bad assumption. A PFMEA asks what can fail before it fails in front of a customer or worse, hurts someone. A control plan makes work repeatable. And an SOP lets good work survive growth and one person who used to remember everything and they're suddenly gone. Somebody needs to remember why. Part of my why is working on things that benefit people with a medical need. One of my first jobs after college was creating a distribution center for international shipments of CT and X-ray machines at GE Healthcare. I wore the hat, without the degree, mind you. I wore the hat of a packaging design engineer, a test engineer, and a mechanical engineer because we were transporting multi-million-dollar, multi-ton shipments all over the world, and the amount of documentation was none. It's extremely important that you understand that engineering is not a team sport. I didn't develop those standards myself. I leaned on other people as well as my own work, but it took a team of people to develop that, to be able to ship multi-million-dollar shipments that take up full truckloads without having anything tip, without anyone getting injured. And all of that work supported when in January of 2020, I'm sure you all can sense where this is going, a disease popped up in China that required us to overnight start packaging, creating, and shipping 10 times the number of x-ray machines that we had been previously to help support the diagnosis and treatment of people with COVID. But again, that would not have been possible without a team of people around me. Careers drift, lives drift, not because people are lazy, but because life is long and pressures compound. And it's easy to keep taking the next step without asking whether that next step is the direction you want to go. Check your why regularly. If you do, you'll spend a career doing work you actually meant to do and can proudly look back on. When your ring catches on a glove or taps on a keyboard, let it interrupt you for half of a second and ask yourself, do I still know why I'm doing this? Congratulations, Lakers. Wear this ring with solemnity and pride, and let it remind you the hands and your why behind it are for. Anchor up.
The term engineer first entered common usage for the successful builders and artisans in the late 18th century when the Industrial Revolution began. It was only after the Renaissance of knowledge, beginning in the 14th century, that a scientific foundation was established to replace the trial and error methods of earlier engineering practices. One of the earliest definitions of engineering was developed by Thomas Treadgold, a famous engineer, architect, and writer. Shortly after the Institute of Civil Engineers of Great Britain was formed in 1818. His definition, the art of directing the great forces of power in nature for the use and convenience of man, was adopted and appears in the Institute's publications. Professor Hardy Cross, in a book of his talks entitled Engineers and Ivory Towers, noted that the use and convenience of man are not always identical. Engineering does not tell men what they should want or why they want it. Rather, it recognizes a need and tries to meet it. Thus, Watt saw the need for steam engines and Bell the need for telephones. Innovation and service are essential components of engineering practice. It is a creative, purposeful, and evolutionary profession. Its practice involves the application of immutable physical laws that can never be violated without penalty.
The professional purpose of engineering involves the pursuit of a learned art in the spirit of public service. By following the precepts of the obligation accepted in public gatherings such as this, the individual engineer reinforces similar efforts of their peers, realizing that in unity there is strength. Decades ago, our engineering counterparts in Canada had this same feeling. They believed that a need existed for the introduction of a spirit of community and cohesiveness among engineers. They believed that a good way to achieve this purpose would be to instill a consciousness of belonging to one another, to themselves as individuals, and to those whom they served. Thus was brought into being in 1926 in Canada what is now known as the ritual of the calling of an engineer. The words of the ritual were written by the English author Rudyard Kipling, who had strong feelings for engineers as the builders of things intended to benefit mankind. In 1953, Correspondence began between the Canadian Wardens for the Calling of the Engineer and the officers of the Ohio Society of Professional Engineers, with a view to extending the Canadian ceremony to the United States. Dean Burl Bush of Cleveland State University designed and held the first ring ceremony on June 4, 1970. 170 engineering seniors and engineering faculty members took part in this first ceremony. Such is the story of the creation of the Order of the Engineer in the United States. It is patterned on the Canadian concept, but with differences, which are distinctly ours. With a stainless steel ring symbolizing the strength and unity of the profession and publicly identifying an engineer. It is difficult to visualize any better symbolism than the continuity of a ring worn for all to see. It says that here is an engineer with a publicly avowed obligation to their profession and to those it serves.
The Order of the Engineer, to which you will soon belong, is an independent organization. The purpose is to foster a feeling of pride and dedication to that profession which binds us together. You are asked to accept with pride the meaning of the ceremony to which you are about to subscribe. The obligation should be freely given and the responsibility gladly accepted. The order is symbolized by the acceptance of an obligation and the wearing of a stainless steel ring on the little finger of the working hand. The obligation is the formal statement of an engineer's responsibilities to the public and to the profession. It is a creed similar to the oath attributed to Hippocrates that is commonly taken by medical graduates and which sets forth an ethical code. The obligation likewise contains parts of the canon of ethics of major engineering societies. Initiates, as they voluntarily accept it, pledge to uphold the standards and dignity of the engineering profession and to serve humanity by making the best use of Earth's precious and limited resources. The obligation is a composite of several creeds. It emphasizes the fact that we, as engineers, have certain obligations. It promotes honesty and integrity and recognizes that today's engineers are dependent on their predecessors for their skills.
The ring, a symbol of pride, prestige, honor, and professionalism among all engineers in the United States, also serves as a reminder of our obligation to society. The symbol of your desire to serve the public is the engineer's ring. The ring you will wear on the fifth finger of your working hand will say to all who see it, "Here is an engineer possessed of a publicly avowed dedication to the profession and the public they serve." It is our symbol. Wear it for all to see. It is a badge of recognition which will become known to all as the sign of a learned professional pledged to making the best of the Earth's precious and limited resources.
Acceptance of the obligation. Will all candidates for induction into the Order of the Engineer please stand and face the audience? Will all current members of the Order of the Engineer please stand? Candidates for the Order of the Engineer is an independent movement. The purpose is to foster a feeling of pride in and dedication to our profession. Your membership in the Order is symbolized by the acceptance of an obligation and the wearing of the stainless steel ring on the little finger of the working hand. There are no meetings other than this ceremony, and there are no dues. It is with humility and the need for guidance that we take this pledge. Raise your right hand and recite with me the obligation of an engineer. I am an engineer. In my profession, I take deep pride. To it, I owe solemn obligations. As an engineer, I pledge to practice integrity and fair dealing, tolerance and respect, and to uphold devotion to the standards and the dignity of my profession.
As is all associations, the same, it's a defined.
Conscious always that my skill carries with it the obligation to serve humanity by making the best use of the earth's precious wealth.
Always builder appreciation very lazy.
As an engineer, I shall participate in none but honest enterprises. When needed, my skill and knowledge shall be given without reservation for the public good. In the performance of duty and in fidelity to my profession,
The permit certainty dealt with fashion.
I shall give my utmost. You may be seated.
All right. Now, in the presence of your fellow engineers, you will be called forward to sign your certificate and receive your ring as an indication of your acceptance of the obligation of the Order of the Engineer. You will then place your working hand through the ceremonial ring and receive your ring as the outward sign of your profession. Faculty who are initiated, if you would like to shake initiates' hands as they process, please come forward at this time. Initiates, you may come forward as we call your name. Friends and family, this is a good time to whoop and holler.
We wanted it, so there, really, she's my way there.
How long does it take engineers to fight whole line? All right, I said that I would embarrass my daughter by saying this, but we like you so much, we're putting a ring on you. So let's go. Sumaya Akhtar.
Matthew O'Leary.
Ben Applegate.
Jaron B.
Step it.
Brian Barrington.
Caitlin Berry.
Bailey Bertzel.
Jacob Boovy.
Andrew Bozma.
Joshua Bowman.
Elise Bradley.
Levi Brame.
Nathaniel Brinks.
Ethan Budd.
Madeline Burrell.
Simulator did it all.
John Bushman.
Erickson Carpenter.
Braden Chittenden.
Hayden Church.
Tyler Coker.
Kyler Cope.
Gavin Curtis.
Rosanna Damon.
Quentin Danier.
Carter DeGraff.
Jay Dar.
Reeve Dumpter.
Jack Doxey.
Joshua Driver.
Yasin Olayevi.
Jonathan Elhard.
Nolan Ellis. Albar Atarnis.
Kyle Emerson.
Luke Ensink.
Eli Enyart.
Luke Erlewine.
Maxwell Ernst.
Sam Fellows.
Alexander Flannery.
Noah Futter.
Matthew Gage.
Gabriel Geit.
Laura Gunner.
John Gold.
Regan Graham.
Libby Dressley.
Jessica Grove.
Caleb Hart.
Adam Pankey.
Caleb Honeycutt.
Mitchell Hundle.
Luke Jameson.
Kyle Jones.
Dakota Johnson.
Jared Klein.
Samantha Knight.
Colin Kraylap.
Casey Kremarsik.
Hunter Krupp.
Nicole Marie Lottie.
Morgan Lefebvre.
Ethan McCauley.
Annika Matson.
Abigail McCallion.
Ben McCarthy.
Christopher Mills. Omar Wael Mokhtar.
Simon Morgan.
McKenna Moles.
Michael Myers.
Brennan Neitzel.
Go, Brennan!
Logan Nicholson.
Luis Ojeda Bosch.
Go, Luis!
Oliana Omanji.
James Howard Patterson.
Rachel Patterson.
Cody Penn.
Gabe Perkins.
Aaron Patrico.
Grant Feaster.
Damian Plender.
Caden Rad.
Paige Rabidou.
Maya Rhodes.
Eli Richter. Ellie Richter.
Dominic Record.
Abigail Throbbins.
Lucas Roberts.
Josh Rousseau.
Rihanna Ruza.
Mahmoud Sali.
Antonio Santos.
Stefan Sarche.
Vincent Scalisi.
Nathan Shaner.
Gabe Shinky.
Grace Shoemaker.
Blake Schramm.
Dylan Schramm.
Hannah Schraben.
Samantha Seneker.
Tasmia Sheikh.
Emily Sherry.
Olivia Dawn Smith.
Trent Spradlin.
Zachary Spradlin.
Cole Straka.
Thomas Stutz.
Joshua Suzio.
Allison Telk.
Leah, Leah Thomason.
Jonathan Thompson.
Alexander Tillery.
Nathaniel Tillery.
Luke Toonstra.
Sure.
Emmett Top.
Joseph Tufts.
Paramveer Tambar.
Emma Rose Valdez.
Patrick Vidovich.
Abigail Jennifer Way.
Jake White.
Lucas Williams.
Sam Zylstra.
Now we'd like to recognize a few groups and individuals. So all of you that are members of the Frederick Meyer Honors College and the Tau Beta Pi Engineering Honor Society, please stand to be recognized. Thank you. And all members of a professional student organization, please stand. And now we'll introduce the outstanding senior projects. So the first one is Team 18, AutoCam Medical Auto Grill Packager. Can members of the team please come up?
Yo, Beezer.
And the People's Choice Award goes to teams 11 and 12, Blue Water Pools Gun and Lakes Crow.
EJ. We
Just like, where's me? Here. You got it.
And now the outstanding students, the Co-op Student of the Year, Tyler Coker. The biomedical engineering student, Maya Rhodes. From computer engineering, Lucas Williams.
this year.
From electrical engineering, Laura Gunner. From integrated engineering, Cody Lampin. All right. Mechanical engineering, Rosanna Damas. Product design and manufacturing engineering, Leah Thomason. And from the Master of Science in Engineering program, Madeline Burrell.
All right. And now for something completely different. I've played too much. So now that we all have our rings, I was going to say something about brightest days and darkest nights, something. As a reference to it. I want to remind us, as a closing remarks that I have to give, I want to remind you of what we were reminded of a couple of weeks ago by Ellen Solasky, who reminded us about what engineering education does for you. A couple of weeks back, you were at the 50 Nights event, and she reminded us that engineering education prepares you to do hard things, teaches you, trains you to do hard things. And tonight, you have all entered a noble profession that is known to do hard things. You have permission now to go out and do epic, hard things, things that are tough, that everybody else will find very difficult to do. But that's what you're trained to do. So tonight, you heard a lot about pride in the profession. You've earned it. You need to walk around now with a little extra balance in your step, a little extra lift in your shoulder. And you should be proud of yourself, proud of the profession. Civilization depends on you. Cannot think of any other profession that is so critical Yes, there are others, but I'd say engineering is probably more critical. If civilization collapsed today, you want to have engineers. And that's what you're all the tasked to do now. So, but I also want to add a little bit to that in addition to the pride that you should have in your accomplishments and in the profession, you should practice with humility. You should remember that. As you collaborate, as you work together with others, remember that you should be humble and you should have courage. Another thing that you should always draw on. Because if somebody asks you, who gave you the right to do that hard stuff? Who gave you the right to think you can have an impact? Just show them the ring. Thank you all very much.